Hello, notes 4.4 are on transformations of trigonometric functions. And the first question asks us to use Desmos to explore the graph of y equals 3 sine of 2 times x plus pi over 6 minus 1. And we're going to identify the characteristics of the function. So let's go ahead and do that. So I'm going to type in y equals 3 sine of 2 times x plus, and then we'll type in pi over 6 minus 1 right here and see what ends up happening. Now, the first thing that I want to do is I want to change some of the information, the key features that we have on the graph itself. So I'm going to go to my graph settings and I'm going to change it. Now that we're in radians, first of all, you have to make sure you're in radians and not degrees. Otherwise, you won't be able to see the proper graph, and we're doing everything in radians for trig in advanced functions. And I think I want to look at it from, let's see what happens from negative 4 pi all the way to 4 pi, and we'll make our step pi over 6 so we can kind of see things a little bit better. And then for our y-axis, let's go from negative 5 to 5, and we'll go up by 1s. Okay, so now that I've done that, I can kind of see my graph a little bit better. I can see what's happening right here. So if you notice right here, my graph is a sine function. So if I want to look at what I have here, in order for me to have a sine function, it has to go from, just like a regular sine function would look like. So let's go ahead and just compare a sine function to what we have here. So we'll say y equals, and we'll go to functions here to get our sine. So y equals sine of x. So when I look at it right here, we know that our sine function starts at the origin, then it increases, and then it decreases, and then it brings us back to the y-axis the x-axis at 2 pi. So we know that it completes one full cycle in 2 pi. Okay, so now let's look at this right here. I want to do a similar idea, but I don't want to get confused with what's happening here. So right here, it looks like to get a complete cycle, we should maybe start right here, and then we can go up, and then down, and then back up right here. Okay? So things are a little bit different with this example right here. Well, the first thing I want to know is, where is my graph centered? So where is this going to, where's my axis going to be, my center line, my center horizontal line? So if I look right here, it's really clear that it's going from negative 4, that's my minimum, all the way to positive 2, that's my maximum. So based on that information, I can say that the halfway point between those two is negative 1. So I know at negative 1, that's probably where my axis is going to be. So let's try it and see what we get. So you get y equals negative 1. And when I graph it out, it's very clear that that's definitely where my axis is going to be. Okay? Now, notice here in my graph, it says minus 1 right here. So I know that I have a value of c at negative 1. So that's really useful to see what that, that letter c value represents. Okay, so now, the next thing I want to notice is that instead of starting at negative 1 and just going up by 1 and down by 1, it actually starts at negative 1 and it goes all the way up to 2, and then it goes back down to negative 1, and then it goes down to negative 4. So if you notice, to go from my axis to my maximum, it's going up by 3, and to go from my axis to my minimum, it's also going down by 3. So this 3 value that we have in our equation is going to tell us how high it's going, or in other words, our amplitude. So let's go ahead and write that information down. So we know that we have an amplitude is equal to 3, which is essentially just our a value right here. Okay? We also know that we have an axis at y equals negative 1, which is essentially just our c value. Let's see if we notice any other pieces of information right here. So now I want to see, well, what's my period? How long does it take me to get through a full cycle? Well, it takes me from negative pi over 6 to 5 pi over 6, that brings me through a full cycle. If you notice right here, I go up and then back down and then back up, so I'm at 5 pi over 6 is a full cycle. So we can figure that out. We can figure out what our period is. So 5 pi over 6 minus negative pi over 6 is going to give me, this turns into a plus, so I get 6 pi over 6, or just pi. So I know that my period is equal to pi, where in a normal sine function, a period would be equal to 2 pi. So if you notice this value right here, we know that this value is our k value. If a normal cycle is 2 pi, what am I doing with my k value to get a period of pi? Just divide it by this 2. So we can say that our period is equal to 2 pi, which is our normal cycle, divided by k. That's a really important equation that we're going to have memorized, okay? All right, and one last observation we should notice is that it's not starting at 0. Our sine function is not starting at 0. In fact, it's starting to the left of 0 at negative pi over 6. So this right here is clearly showing us our horizontal shift. But let's delete it and see what ends up happening if we delete it and see if it's really going to start at 0 for us. So take away this pi over 6. Right here, and when I look at it right here, it does start at 0, goes up, goes back down, and it completes a full cycle in pi. So that means that we are good to go for this. So that means that we also have a horizontal shift to the left by pi over 6 units right here. So this right here is going to be our d value. And we also, I forgot to label this right here, our c value, okay? So those are key characteristics of our function that we have right here. Therefore, we can conclude that if we have a general equation of y equals a sine of k times x minus d plus c, that a is going to give us our amplitude. Okay, and normally we would say A gives us our vertical stretch or compression, but when we've got an amplitude, that tells us how high or how low it's going. So it's clear that amplitude and vertical stretch compression go hand in hand when we're talking about sinusoidal functions, okay? We can also conclude that our k value will tell us our our horizontal stretch or compression. But this really is more affected, this will affect our period more than anything else, right? So we know that 1 over k gives us our horizontal stretch or compression. But a key piece of information is that the period, and we already wrote this down, is equal to 2 pi over k. But we want to put k in absolute value bars because it doesn't really matter if k is positive or negative with regards to our period. But if k is less than 0, then that means that it's going to reflect in the y-axis. Okay? Okay, so now our d value right here, this d, is going to tell us our horizontal translation, just like it does with any other function that we have, okay? And then our c value is going to tell us our vertical shift, our vertical translation. But c, so vertical shift, we'll write down that c is our vertical shift, but what's key is that the axis of our equation, the equation of our horizontal line of our sinusoidal function will be y equals c. Okay? Really key information that we have here with regards to transformations of trigonometric functions. All right, so let's apply this information to a real-life example. So it says that a mass on a spring is pulled toward the floor and released, causing it to move up and down. So we know if we have our spring, it's going to go down and then it's going to go back up. So if I were to model it with time, it would look like something similar to this, okay? Its height in centimeters above the floor after t seconds, so t stands for time, is given by this function h of t equals 10 sine of 2 pi t plus 1.5 pi plus 15. between 0 and 3 seconds. So I want to sketch a graph of the height versus time, and then we're going to use our graph to predict when the mass will be 18 centimeters above the floor as it travels in an upward direction. Now we have two pieces of graph paper here because we're going to look at what happens before we do our horizontal shift, and then we'll apply our horizontal shift afterwards. So this will be our final answer right here, our final graph, okay? So first thing I want to do is analyze what my equation is saying. So it says h of t is equal to 10 sine of 2 pi t plus 1.5 pi plus 15. Well, first of all, in order for me to get it in this format right here, I need to factor out my k value right here. So in order for this to be just t, I'm going to factor out a 2 pi. So I can say h of t is equal to 10 sine, and then in order to factor out the 2 pi right here to get this t left over, I end up getting 2 pi times t plus, and then when I factor out 2 pi from 1.5 pi, when I divide that, I get just 0.75 plus 15, okay? So now I can go ahead and figure out all of my information. Well, I know that my amplitude is going to be equal to 10, okay? I know that my period, so my period is going to be equal to 2 pi over k, and I know that my k value is 2 pi. So I know that this is going to be completed, one cycle will be completed in 2 pi over 2 pi, or just 1, okay? So the period information I also know as well. Okay. Now as for my horizontal shift, this right here is telling me my horizontal shift, so I know d is equal to 0.75. So that means that it's shifted 0.75 units to the left, okay? And we know that c is equal to 15, so my graph will shift 15 up, but what that means is that the equation of my axis is going to be y equals 15. Okay, so let's go ahead and see if we can put this information into a graph. We're going to look at the amplitude, the period, and our axis, but we're going to ignore our shift for right now. Okay, so we know that t stands for time, and that's going to go on our x-axis right here. So I'm going to put my time on the x-axis, and then I know that my height is going to go on my y-axis. Okay. So this is what I have right here. I'm going to label my axes. So we'll call this time, and we will call this the height. So this is h of t, and this is t, right? And our time, we know it's from 0 to 3, and I'm going to go by quarters. So I'm going to put a whole number every 4 spots. And the reason why I'm going to do that is because a lot of times when we look at our sine graph, we look at it in terms of pi over 4, or we look at it in terms of quarter segments, and I'm going to do the same thing for this graph as well, okay? And then as for my height right here, I know that my axis is going to be y equals 15. So this is my middle value. And I know my amplitude is 10. So 15 plus 10 is 25. So I know that that's going to be my maximum because the amplitude is going to tell me how much higher than my axis it's going to go. And then the minimum is going to be 15 minus 10. So it's going to be 5. So I know my minimum is going to be 5. So I think if I need to go from 0 to 25 somehow. So if I go up by 2s, I think that would be an appropriate scale. So 12, 14, 16, 18, 20. And then this right here doesn't go quite up to 30, so I'll just say that it's 28. What we want to do right now is we want to look at how the sine function is going to relate to these 3 things that we said we identified we're going to transform right now. So if you look right here, our equation of our axis is going to be y equals 0 because that's where my symmetry is happening in my sine graph right here. But we figured out that our equation of our axis right here is going to be y equals 15. So I'm going to go ahead and graph out the line y equals 15 right here. So I know that that's where my equation for my axis is going to be. Okay, and normally it would start at my equation of my axis right here. So we have the same idea in this graph right here. My starting point is going to be on my equation for my axis. So I know for sure it starts at 0, 15, excuse me. Now, if we look at our original sine function, we know that it takes a period of 2 pi to complete one full cycle. So if I look over here, we know that it takes a period of 1 to complete one full cycle. So I know between 0 and 1, I'm going to have a full cycle right here, okay? So I'm just going to draw a vertical line so I know that I have to complete a full cycle between 0 and 1, but I'm going to erase that vertical line eventually. Okay, so now I also know that I'm going to reach my maximum point about a quarter of the way through my cycle, because if I split this up into quarters, 1, 2, 3, 4, my maximum occurs at pi over 2, which is a quarter of 2 pi. So what's a quarter of 1? It's just 0.25. So I know that at 0.25, I will reach my maximum, which we figured out was 25. So I know that at 0.25, I'm going to go up to 25 right here. Okay? If I look at my original function, the next 0 occurs halfway through my cycle. So since my full cycle is 2 pi, my next 0 is at pi, which is half of 2 pi. So right here, I know that half of 1 is 0.5. It's going to reach the middle, the axis point right here. Okay? And then after another quarter of a cycle, I will reach my minimum right here. So my minimum is going to occur after another quarter of this cycle, which is at 0.75. And we figured out that our minimum right here, if you remember, is 5, okay? And then it brings us back to our full cycle right here. So that's what it's going to look like, and I would just keep going with this whole idea, okay? So again, I need to complete another cycle between 1 and 2. So between 1 and 2, it will bring me back to my axis. Halfway through, I will also be back to my axis. A quarter of the way through, I'll reach my maximum, and 3/4 of the way through, I'll reach my minimum. And I'll just do it one more time for my third cycle right here. So my halfway point, I know will reach my axis again. Quarter of the way is my max. 3/4 of the way is going to be my minimum, and then I can connect my dots right here. So this is what my graph is going to look like right here. Okay, but this is not the original function. This is just h of t is equal to 10 sine of 2 pi t plus 15. I haven't done my horizontal shift yet. So that's what we're going to do right here now. So how is it shifted? It shifted 0.75 to the left. So we're going to set it up exactly how we set everything up before. So I'm going to have you take a couple seconds, pause the video, set up your graph with your x and your y axes exactly how we had before, and then we'll talk about how to do the graph for this. So now that I have my x and y axes labeled and ready to go, I'm going to go ahead and draw in my axis right here, because I know my axis will occur at y equals 15. So I'm going to draw that in. And I will see what I can do from there. So I know right here, this is where my axis is going to be happening. And I'm going to be comparing my graph on top here to do my graph on the bottom over here. So I know that everything is shifted 3/4 to the left right here. So I'm going to take the 0.75 right here, and I'm going to shift that 3/4 to the left, and my new point should be down here. I'm not dealing with these ones right here because this will bring me into negative time, and I don't want to worry about that. So my first actual value here that's going to help me out is when time is 0.75, I shift it back 0.75, and I know that when t is 0, we should be at our minimum of 5. Okay, and then for it reaches our axis at 1 second, move back 3/4 of a second, and it brings me to 15 right here at 1/4 of a second. Okay, then we know that the next value is going to be our maximum right here. So this is going to be 25. We know that the next value is going to be at our axis, then it goes to our minimum, and we can just keep going with that. We've developed a pattern, we figured out what's happening, and then this is what our graph is going to look like. Okay, and we go all the way up until we get to time of 3 seconds. So we're almost there right here. So then once I've done this, my graph will end up looking as follows. And I'm not putting arrows on my graph because we've got a specific domain. It's just from 0 to 3 seconds. So this is what my graph right here will look like. And this is the actual final equation. So this one right here is going to be my h of t equals, and then the full final equation that we have right here. So I'll go ahead and write that out, and we will be good to go with our graph for this problem. Okay, so now the next question says, then use your graph to predict when the mass will be 18 centimeters above the floor as it travels in an upward direction. The h represents the height above the floor. The higher the height, the farther away it is from the floor, which means that it's traveling in an upward direction here. Then it starts to go back down. Then it starts to go back up, down, okay? And we want it to be at 18 centimeters above the ground. So in order for me to figure that out, I need to have another vertical or horizontal line to see where this is true. So I'm going to go to 18 centimeters above the ground. So here is my 18 centimeters. And it's clear that it's equal to 18 centimeters on the following points. So right here, as well as here, 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 here. So we've got 6 points where it's true. However, this is going down, so this is not in an upward motion. This is going up, so this works. This is going down, this is going up, so that works. This is going down, so that doesn't work. So where does this occur? Well, it occurs around here, around these times that we have right here. So therefore, we can say that our answers are on its way up, the spring is at a height of 18 centimeters at about, and then we're going to figure out our answers here. This is a little bit more than a quarter, so we'll say 0.3 seconds. This is a little bit more than 1 1/4, so we'll say 1.3 seconds. And here we've got about 2.3 seconds. Okay, and that's our answer to question number 2. Okay, question number 3 says the following graph shows the temperature in Nellie's dorm room over a 24-hour period. Determine the equation of this sinusoidal function. So remember, we have a bunch of things that we need to figure out. We need to know the amplitude. We need to know the period, which will tell us our k value, okay? We also need to know our equation for our axis, and we also need to know what our horizontal shift is. Okay, so looking at this right here, let's go ahead and begin to figure this information out. Well, my amplitude is going to tell me how high up it goes from my axis. So the first thing I'm going to do is find out what my axis is, because that's going to really be helpful to me. So for my axis right here, I know my axis is the halfway point between my minimum and my maximum. So we know that our max right here occurs at 25, okay? So 25 is our max, and we also know that our minimum here occurs at about 13, okay? So that's going to be our minimum. So to find our axis, we're just going to find the average of our max and our min, and we'll go from there. So we know that our max is 25, our min is 13. When we add those together, we end up getting 38 over 2, which gives me 19. So the equation of my axis is going to be y equals 19. Okay, now when I graph that out, that should seem to make sense. Let's go ahead and try this and see if it does make sense or not. So for my axis right here, I'm going to go to 19, and I'm going to graph out my line. And that seems about right for me, because this is marking pretty much the halfway point, or that line of symmetry for my sine function that I have here, or my cosine function. So we're good to go for our axis. Based on that, I can now figure out what my amplitude is. Now my amplitude is going to be to find the amplitude, all you have to do is take the max and subtract the minimum and divide that by 2, because I want to know how much higher it is, how much higher the maximum is than the axis and how much lower the minimum is from the axis. So subtract those two values this time. You end up getting 12 over 2, which is 6. And 6 should make sense to you because 19 plus 6 right here will bring me up to my maximum of 25, and 19 minus 6 will bring me down to my maximum, or my minimum of 13. Okay, so we're good to go for our amplitude. Now, let's figure out our period and use our period to help us figure out our K value. By the way, this right here is going to tell us our C value. This right here, the 6 is going to tell us our A value, okay? Now we're going to use our period to figure out the K value. So to find our period, I want to know how long it takes to complete a full cycle. Well, it tells me in the problem that it's her dorm room over a 24-hour period. We already know our period is 24. We also know that the period is equal to 2 pi over K. So I know the period is 24. I can use that information to help me solve for K. So I'm going to multiply both sides by K to help me isolate this K right here. So 24K equals 2 pi, which means that K equals 2 pi over 24, or just pi over 12. So I know my K value now is pi over 12. So that's going to also be key right here, okay? And then lastly, the last thing I need to do is figure out what my horizontal shift is. So I want to figure out what my D is. Well, in order to figure out my D, I have to decide, do I want to do a sine function or a cosine function? Essentially, they're interchangeable. They're pretty much going to be the same idea, except your shift will just be in a different place. Instead of doing a sine function, I want to do cosine because I want to do one of each. Since our last problem was sine, let's look at cosine. And we know cosine starts at our maximum, so we know that cosine is going to start somewhere around here. So we know that it's shifted 17 to the right. So we know that D is 17, okay, because it was shifted 17 to the right. So now, based on that, I can write all my information out. I can say y equals cosine of K times x minus D plus C. So let's go ahead and fill in that information. We know our amplitude we figured out was 6. So we're going to say it's 6 times the cosine of, we figured out our K value was pi over 12, times x minus, we know that our D value is 17, and then plus C, we know that our C value is 19. So it starts at 19, and we have our equation based on all of our different characteristics that we figured out in this graph right here. Okay?